In this video, we're going to take our previous HMI project that we created for an Automation Direct Seymour Micro HMI unit. We're going to expand it to show the value of a counter that's been programmed into our Allen Bradley Micrologix 1000 PLC. Before we do that, I will show you the program that's in the Micrologix. Right now we have an input contact. It is our first switch, bit 0, and it is incrementing an up counter. We have our second switch, bit number 1, which is going to be activating a reset coil to reset this counter. So this counter is a file type C for counter, file number 5. It's the 0th element, so we're talking about the counter 0 here in the Allen Bradley scheme of addressing. We're going to go back here to our Seymour Micro HMI configuration software, and as always, first thing we need to do is populate the database with an appropriate tag so we can associate with that counter's value. So we're going to go to the tag name database. I'm going to add a brand new tag name. I'm going to give it a name. I'm going to call it counter value. I also need to specify the proper type. It is a signed integer, 16-bit. We go to the memory type in the PLC, and that is the letter C, standing for counter. And here's where you specify the address of the counter in the PLC's memory. This is file number 5, element 0. That's very important to include all that information right there. And the flag is going to be the accumulator value of that counter. So it's counter 0, file number 5, counter type, accumulator flag. We're going to add that tag name to the database. And so here we have a brand new tag name called the counter value, signed integer 16-bit, PLC address c5:0.acc. And it's in device 1, which is our PLC. It also has a read-write attribute, so we are able to not only read this value with the HMI, but also write new numerical values to it if we wish. This, of course, is in addition to the two tag names we created earlier, switch 0 and switch 1, which are both discrete and are addressing the input bits of our PLC. So I'm done with that part. I can go back to my graphic display. I go over here to my object list and pick up a numerical display object. I'm going to place it on the screen, and I want to associate the proper tag with it. Right now the only appropriate tag for the numerical display is the counter value tag name that I just created in the database. Now this tag name is associated with the data type of signed decimal. It already knows that from the database. The number of digits, total of 3, and I can even specify fractional digits if I wanted to force a decimal point to appear in the display for a fixed point type of number representation. Right now I just want to show it as a whole integer though, so my fractional digits will be 0, and I can have a total of 3 digits in my display. I can turn that up or down as I wish, and that will of course change the width of my display, the indicator on the screen. I'll now click OK, and right there is my indicator. I can stretch it out, I can make it narrower, I can adjust its placement on the screen, and right there I should be ready to go. Now I'm ready to send my project to the panel. As always, I've ensured that my panel has been set to the Setup menu screen, which is a step you must do with the Automation Direct Seymour panels before you can transfer any new projects. So I've set that up, pan back over to the software, and I click Send Project to Panel. I'm saving it under new file name. There we go. I'm going to transfer the project. It's reading the panel information, and now transferring the data. As soon as this is done, it will alert me that the file has been transferred, and then I should be able to go take a look at my HMI and see if it works. And here we go, project transfer complete. So I pan back over to my HMI. I'm going to show you in a way you can actually see the input switches on the PLC, these toggle switches over here. So now you can see the HMI screen. I've got my two indicators telling me the status of the two switches, and I've got my integer indicator right there. As I toggle the first switch on and off, you see that rectangular indicator flashing on and off telling me the status of the bit. And you also see the readout here. It's currently at a value of 10. You can see it increment because the counter in the PLC's memory is incrementing. Now recall that my second switch, input number 1, was connected to a reset coil in the PLC's program. So as I turn it on, you'll see that comes on and the counter value goes to 0. So now I have myself a display showing me what the counter is doing inside the PLC. So we have a program in the PLC that counts, and we have a complementary program in the HMI that displays what's going on with that counter.